Welcome to day 2 of conditional probability. Today we will be spending most of our time looking at how to use tree diagrams to help us to find things using conditional probability. So today you're going to also have some math Excel problems to work on through the end of the period. So let's get started with the basic idea of what a tree diagram is. It's a way to organize, and it's a different way to represent a sample space. It's there to try and help us to organize things. So here's an example of a tree diagram of a coin toss. What we do is we're going to say that we have two branches. Our two branches represent the two different outcomes. I can either get heads or tails. We write on the branch what the probability is of each of these things happening. 50% for heads and 50% for tails. And then all you do is you just list, what you've got in terms of options. Okay, let's scroll down here a little bit, and we extend this tree diagram to show two different tosses of the coin. So I'll do that now, and you can see once again, what I say is on the first toss, I got heads, but I also have the possibility of getting heads or tails on the second toss. Once again, I list my probability of the first one, and I list the probability of each of my others. Okay, should be fairly easy to follow in terms of that. Now, how do we actually calculate what the probabilities are going to be? Unlike having to use a formula, it's a little bit easier. Because we're doing things multiple times, we're going to be multiplying along the branches. Remember what we did with the independent and dependent, that ended up being something where we multiply. Again, because we've got different events, we're going to multiply. And then we add the probabilities down in columns, and I'll explain what that means here. If I'm trying to find what the probability is that I got heads and then heads, that means that I'm going to follow the path. I go along here, and you can see I got head the first time, and I got heads the second time. And then what I need to do is I need to say, well, I'm going to multiply 0.5 times 0.5 to represent that. And so when I multiply those two things together, I get my overall probability of that happening, which is 0.25. Now, if you're trying to make sure that you did everything right, what you can do is you can add your probabilities that you end up getting at the end up, and that should always add up to be 1. Okay, hopefully that makes a decent amount of sense. Let's see what we can do about moving on from there. And we'll take another case that's similar to something we've done previously. We're going to say we've got a bag that contains 4 red marbles and 6 yellow marbles. Okay, how do I go about doing something like this? Well, I'm going to list my outcomes. I can reach into the bag and I can grab a red marble. I could also reach into the bag and I could get a yellow marble. Now, those are possible outcomes and I've listed them. But I also need to talk about, well, what is my probability of each of these things? Please note I had 4 red, 6 yellow, which gives me a grand total of 10. So my probability of getting a red marble was 4 out of 10, or 0.4. And my probability of getting a yellow is going to be 0.6. Everybody should be fairly comfortable with that. And let's see what we can do on this here. Well, then we're going to randomly select 2 marbles. Note it has replacement, so I put the marbles back in. What are possible outcomes after I've drawn my first red marble? Well, I could draw a second red marble. I could draw a yellow marble, and I could also go down here, and after drawing a yellow marble, I could draw a red marble, and I could draw a yellow marble. And now again, I need to list my probability on that particular branch. So what I'm going to say here is that my probability, because I've put the marble back in, I've replaced my marble, I'm back to having 4 out of 10, so I'm going to say 0.4 there. And I've got 0.6 here. Down on this bottom one, I also have 0.4 in terms of probability and zero 0.6 in there. Now, you are trying to find what is the probability of, it says, of selecting two marbles with replacement. Okay, so that's my overall probability. And what I can do is I can say, well, in part B, what is the probability of selecting two marbles that are different colors? There's two ways I could do that. I could do that by drawing a red marble and then a yellow marble, or I could have kind of followed this path down here and drawn a yellow marble and a red marble. Okay, here's the top one, red, then yellow. Now, what I need to do is follow this path, and I'm going to multiply the numbers that I get as I go along that path. Fill this in, yellow, red. And in order for me to do that, I am going to multiply together 0.4 and 0.6, which is going to get me 0.24 of getting red then yellow. And I'm now going to do the same thing down here, and I'm going to say 0.6, a chance of getting yellow, and 0.4, a chance to get red. Once again, I end up with a probability of 0.24. So the probability of selecting the two marbles that are of different colors, well, I'm going to add them up because I have to add these two percentages together, which is going to get me 0.48 or a 48% chance of that happening. Okay, so far so good. Next, we're going to do the same problem, except this time we're going to do it without replacement. And how does that change things? Well, let's see. Let's start off with the basics again. What are my possibilities of things that can happen in terms of outcomes? Well, I could get red for my first marble, or I could get yellow for my first marble. Again, the probabilities are the same, 0.4 and 0.6. But then I don't put the marbles back. So what I'm looking at in terms of probability is I started off with 4 red marbles out of 10 marbles. But because I've drawn 1 red marble out, that leaves me with 3 red marbles still in the bag. And I no longer have 10. I've got 3 out of 9, or 1/3, or 0.333 repeating. And I'm going to say, well, that would get me my probability of getting a red marble. Next, I'm going to do the same thing here, and I'm going to say, well, I still have 6 yellow marbles, but now, once again, when we're trying to figure out my probability of getting a yellow marble, I've only got 9 marbles because I drew the red one out to begin with. So I've got 6 out of 9, or 0.666. Okay? And I've got that information. Let's see what we can do on this one down here. Once again, my possibility of results are going to be I could draw a red or I could draw yellow. And we have to once again redo my probabilities. Now, assuming that I drew the yellow marble first, I'm going to get rid of this information up top. Okay, I'm assuming that I drew a yellow marble first, and I started off with a 6 in 10 chance. Now, I now only have 9 marbles in my bag, and I've got 4 to choose from, so I plug that in. So I'm going to be looking at 4 out of 9, which, as it turns out, when I put this into I get 0.44 repeating. And I'm going to try the same thing when I do it with my yellow marbles, except this time, since I've drawn 1 marble, and the marble I drew originally was yellow, I've only got 5 yellow marbles left. So that's going to get me 5 out of 9, or 0.55 repeating. So, and the question I'm being asked to do again is find the probability of selecting 2 marbles that are different colors. Now we're going to follow the path and multiply my numbers again. So I'm going to say I went red first, and then I go yellow. Again, looking at a result that goes red, then yellow, and then I'm just going to multiply together 0.4 times 0.666 repeating, which is going to get me 0.266 repeating. And I'm going to try and do the same thing on the other end. We're going to go yellow and then red. And once again, I'm going to multiply together my probabilities. And guess what? I get the same thing out again. Now, it's not always going to come out to be the same, but these numbers do line up very nicely for us. Now, what I'm looking at is I was asked to find the probability of selecting two marbles that are different colors. So those are the two different ways. I'm going to add together their probabilities, and I'm going to say I'm going to get 0.533 repeating, or roughly 53.3%. Okay, so far so good. All right, let's take a look at a slightly different problem. We have a school system that compiles the following information on a survey it sends to people who were juniors 10 years earlier. Let's see what we've got in terms of information here. It says 85% of the students graduated from high school. Okay, and so we've got graduating high school, and then we've got whether or not we're happy with the present jobs. So this first tree is going to be, did you graduate from high school? So I'll put a notation here and I'll say this one was a grad and this one was not a graduate. And from the information they told me up at the top, it says 85% of the students graduated from high school. So I'm going to say that's going to be 0.85. Well, in 0.85 graduate, that leaves me with 0.15 that did not graduate. Okay, so far so good. Next, keep filling in information. We're talking about happiness in jobs. And I'm going to say, all right, let's go to happiness. It says that 90%, if you graduate, 90% are happy with their jobs. So I'm going to say happy. And then down here, I'm going to say not happy. And let's look at the probabilities I'm supposed to work with. Well, it says 90% are happy. So I'm going to say that's going to be 0.9. And then I'm going to go down here and say that that's 0.1. Right? And I'm going to complete the tree diagram by saying of the students who did not graduate from high school, it says 60% are happy with their present job. So I'm going to say, okay, I've got 60% are happy. So there's my happy, and there's 0.6, and this is not happy. And that's going to be 0.4. Okay, so I've now got my information, and I need to see what sort of calculation I need to do because I've got my tree diagram. It says, what is the probability that a person from the junior class 10 years ago graduated from high school and is happy in his or her present job? So I'm going to follow along my path, and I'm going to say, okay, here's my graduated from high school, and here's my happy. So in terms of doing the work, I'm going to say I've got graduated and happy, and I need to multiply 0.85 times 0.90. And I'm going to say, well, that's going to get me 0.765. Again, putting this in my calculator, or I'm going to be looking at 76.5%. So I've now done the work there. So I go down to answer my question on that, and I'm going to say, oh yeah, 75% or 76.5%. So far, so good. Next up, what is the probability that a person from the junior class 10 years ago did not graduate, but is still happy in his or her present job? Okay, and this time I'm going to follow the path that leads me down that one. These are my not graduated, but still happy. So I'm going to say not graduated, but happy. And what I need to do is I'm going to need to multiply together my 0.15 and my 0.6. That's going to get me 0.09 or 9% chance. Okay? And that's a person chosen at random was part of that group. And so I get down to 9% there. Okay? So far, so good. Let's keep going and take a look at this next one. It says a football team has a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it does snow. Suppose that there's a 50% chance of snow. Make a tree diagram to try and figure out what the probability is of the team winning. Okay, so we've got two different characteristics. I've got the fact that it could snow, and let's see, if it snows and winning. So I'm going to try and set things up with the snow first, I guess. So I'll say if I get snow, and this is no snow. And again, it's a 50% chance, so I'm going to say 0.5 snow and 0.5 no snow. Again, I'm taking that information from there. Next, we talk about this stuff and it says the football team has a 70% chance of winning when it doesn't snow. So I'm going to say winning because it's not snow right in here. So I'm going to say it's a 70%, so that's 0.7% chance of winning. And then I'm going to say losing, and I'll say it's 0.3, though technically I'm sure somebody wants to argue with me and say it could have been a tie. And then let's take a look at the top one. It says, well, if it does snow, my winning probability is going to be 0.4, and my losing probability is 0.6. And we're trying to find the probability that the team will win. So I'm really only concerned about this and this in terms of what I'm going to need to find my path on. So I'm going to say I'm going to follow my first path, which is snow, to get to winning. And in terms of things I got snow and I got a win. So I end up multiplying 0.5 and 0.4 together to get me 0.2 or 20% chance. And then we're going to follow the other path on this one, and we're going to go to winning, and we're going to say, okay, 0.5 with 0.7 to get to winning. And in that case, we're now going to go with if we have no snow and still get to winning. I multiply things out, and I'm going to get 0.35 or 35% chance of winning. Okay, so once I've gotten myself to there, I'm going to say that's diagram to find the probability that the team's going to win. I'm going to sum these things up, and I'm going to say I've got a 55% chance of my team winning based off of the current weather conditions. Okay, now let's see what we've got next. Ooh, we've got a tree diagram that's already done for us. Yay, that'll be easy. So the tree diagram relates snowfall and snow closings or school closings. H, L, O, and C represent heavy snowfall, light snowfalls, schools open, and schools closed. Well, let's find our probabilities for everything here. So let's see what it's got. It says the probability of it being closed. Well, what I'm going to do is I'm going to track my paths, and I'm going to say, okay, I get to a school closing there by going along this path, which means that I am now going to say I get there by saying I've got 0.4 times 0.8, and that's going to get me 0.32. And I also have this second path that leads me to school closing, which is going to be here to there. And so in that case, we're now going to, we're going to say that we can go with 0.6 times 0.3, which is going to be 0.18. And I'm going to add down, and that's going to get me 0.50. So my probability of the school being closed is 50%. So far, so good, I'm hoping. Next, let's take a look at this next one. Probability of heavy snow and remaining open. Okay, that's only one situation, so I only have to follow that path here. This goes to, sorry, didn't take it for some reason. Something like that. So I'm now going to be looking at 0.4 times 0.2, which is going to get me 0.16, or let's see, we've got that H and O. Oh, sorry, that's not right. That's 0.08, or an 8% chance of heavy snowfall, and yet the school remains open. Okay, next, let's see what the next thing they're asking me for on this. Okay, it says probability that there is low snowfall given that it's open. Okay, we're going to have to go back and use our formula from yesterday. We're going to say, well, my formula was the probability of L and O over the probability of just O. Well, I'm going to have to try and get some information in order to do that. What is going to be my probability of L and O? Well, let's scroll back up, and I'm going to say, well, what was L and O? L and O would be following along this path in here. That way I get both the L and the O, and that probability ends up being 0.6 times 0.7, which is going to be 0.42. Okay, so I'm going to scroll down to the bottom here, and I'm going to say that that is going to get me 0.42. And then I need to go back up here. Let me erase this. And I need to find the probability of O. Now, interestingly enough, I don't have to do this fully because I know the probability of being closed is 50%. Well, if the probability of being closed is 50%, that means that my probability of remaining open is also 50%. So I can just say that's going to be like that. And so what I end up doing is I take this, pop it in my calculator, and I end up getting 84% chance. Okay. And next up, let's see what we've got on this. The probability of having heavy snowfall given that the school is closed. Okay, we're going to use the same sort of limitation. So we're going to say probability of H and C over the probability of closed. Now, we already have the probability of closed from back over here, so I'm just going to pop that down here, and I'm going to say that that's going to be a 50%. And the probability of H and C, let's scroll back up, and I'm going to say, well, I need to follow along this path. That way I get both H and C. And so we're going to be looking at 0.4 and 0.8, which is 0.32. And so what I end up with down here is going to be 32 divided by 50, which is going to be 64%. Okay, folks, that's all I have for you today. So I'm going to say go ahead and dig into your Math Excels and hope things go well for you. Good luck, all.